Hey everyone. I've noticed over the past couple weeks that my posts are getting a little bit more confusing as I tend to just post bigger piles of parts with no indication about how I intend to put them together. So I thought a good idea would be to go through my digital file, rebuild this thing from the bottom up digitally so you could see what I'm printing, how they're going to go together, and ultimately how this BB-8 droid is going to drive around. So this is the main drive portion of the BB-8. I deleted out a lot of the head stuff up here for this video just so that we could focus on how this wheel, the big plastic white wheel, is going to drive around via remote control, and ultimately how the BB-8 is going to be moving side to side and back and forth. I'll probably do another video on the head movements as I finish up the design for all that stuff. But for now we could strip this down to the beginning and rebuild it from scratch. So here's the axis. The cool thing about this design, and this design is James Bruton's design. He is the proprietor of X-Robots. He has a website, xrobots.co.uk, and a YouTube channel called X-Robots, where you can see pretty much what I'm about to show you spread out over quite a few videos. I'm going to try to consolidate all of that for the purposes of explanation. So the cool thing about this design is that it works on all axes. There's going to be a motor controlling rotation around each one of these axes. We'll start with the X, which is going to be the main wheel. The main wheel rotates around the X axis, which will give us our front to back movement. The way that this wheel is ultimately going to be propelled is with a windshield wiper motor, which I have right here. This windshield wiper motor came out of a 1998 Dodge Ram. I wanted to get one out of a nice big beefy pickup truck because I wanted to get as much torque as I possibly could. This one pulls about 72 pounds of torque, which is good because this droid is going to be really heavy when it's all said and done. I think it's actually going to be about 60 to 65 pounds. Right now it's probably clocking in at about 50, and I'd say I got some more stuff that's got to go in there. So yeah, I think 65 pounds is probably a pretty conservative estimate for the final weight of this thing. Anyway, this motor is going to sit in the bottom of the wheel, and attached to that is going to be a 3D printed wheel of two parts. It's going to have this white part on it, which is solid plastic, and that's going to attach directly to the motor. And then attached to the white part is going to be a tire, and this tire is printed with a filament called Ninja Flex. It's basically simulated rubber, and it works pretty well. You could choose the infill density and choose something super solid, super squishy, or anywhere in between, depending on your needs. Everything you see green from here on out is going to be printed with this Ninja Flex. This is printed at about 90% density, so it's pretty stiff. There's going to be a lot of weight putting down on this thing, so it's going to give a little bit and hopefully grip the bottom of this ball really well. Because this is ultimately what's going to give us all of our forward to backward motion and speed, and a lot's riding on this wheel. So how it's going to fix to this internal structure here is with a motor mount that is also 3D printed. This mount screws into the actual bracket of the motor. I'm going to hide the big wheel so we can see this. So here's the actual motor mount holes, and the motor mount goes right through the brackets of the motor. It has a recess for the wheel, and this will sit nice and snugly on the bottom of the wheel. And this is going to attach to a larger structure called the banana. The banana is going to be the main carriage that drives this motor around inside the wheel. This is going to keep it as stationary as possible in the bottom of the wheel, and it's going to give some good grip to the sides and bottom of the main wheel using these other wheels, these little outside wheels here. Let me hide all that. And these inside wheels here. Now these wheels are going to push out against the inside of this. The big wheel has these structural rims going along the inside. If I hide everything but them, you'll see. So the outer wheels will push against these structural rims and kind of create like a little track for them. So they push against there. These little wheels, these little wheels here, these two and this one, are going to push against the outside of the actual wheel. So all this pushing and all of this pulling is going to give some tension against the wheel while this big Ninja Flex wheel runs the motor along the inside of the ball. So I think I have this set up correctly that I could just rotate, and you'll see that this is kind of what we're talking about. So this carriage would rotate all the way around if I let it, but the weight of everything is going to keep it centered here. So rather than the carriage traveling around the wheel is going to travel around the carriage, because all this weight is going to keep this big wheel at the bottom. And that's what's going to mainly give us our front and back motion. If I reset everything. So this wheel driving is going to push us front and back, and that's going to give us all of our rotation around the x-axis. So now let's talk about the y-axis. Attached to this banana is actually going to be a aluminum tube, which I have here. And this represents the y-axis pretty well because it runs directly along the y-axis while centered pretty well on the x and z. And now this is going to stay stationary. Well, not stationary. It's going to stay stationary within the banana itself, as you can see. And attached to this is going to be a whole nother motor setup, which is going to rotate along the y-axis. And that is called the trousers. These names are all patented by James Bruton himself. The trousers look like this. These guys have bearings in these big recesses. I didn't model the bearings, but these things will hang on these on this axis, and it'll rotate just like this. Now, the purpose of these trousers is to give us side-to-side mobility along the y-axis. So how we're going to do that is printing another motor mount here, which will attach to the trousers, which will obviously hold another motor. Now this motor is going to have a toothed wheel. Let me hide this giant wheel again so we can see a little bit better. Now this wheel here, this little toothed wheel, is going to run along a track, and that track is going to be attached to the original motor mount, and it's going to kind of be like a rack and pinion, only not quite, because this wheel is pretty squishy. This wheel is going to squish and grip this track as best it could as it rotates. Now if we grab the trousers and rotate them, you can see that this wheel is pretty much going to ride along that track pretty true. And this is going to give us rotation along the y-axis. And the purpose of that is to give one steering. We're going to steer left to right this way. And it's also going to give automated stability when we get the motor controller set up. So how is it going to do that? Because attached to the trousers is going to be a gigantically huge, awesome flywheel. So these hangers are going to hold this flywheel. Oh no, phone's ringing. Hang on. Okay, sorry about that. I'm not sure where I left off. Probably something about a giant, massive flywheel. So yeah, the flywheel here is going to be attached to the trousers. And then if we rotate those, you'll see that this entire mass is going to follow that track. Now this flywheel is going to weigh about, I have it at 15 pounds now, and if you include all the plastic and this big metal Lazy Susan I have on top of it, it's probably going to weigh around 18 pounds, and that's going to be swinging like crazy. So this is going to counteract any wobble that comes in from the wheel, and it's also going to steer. So as I'm driving, if I tilt this way, this flywheel will ultimately stay parallel with the ground, and the entire wheel will tilt the other way. And that's what's going to give me some steering as I drive along. Yeah, that's pretty much it. That's the entire drive mechanism. It's two main motors. Oh, sorry, I forgot about the Z-axis. Haha. So yeah, this actually isn't done yet, but there's going to be two more motors. One right in here, which is going to push up against the inside of the flywheel, and another one over here, which is going to do the same. And then there's going to be a control on the remote that's going to spin this flywheel. This big gray ring structure here is actually a Lazy Susan bearing. So this whole flywheel spins totally freely. Like you can almost blow on it and this whole 15 pounds will spin around like crazy. So when we get these motors spin it up, this flywheel will spin super fast, and then you could change direction and have the entire droid spin in the spot. So that's going to give us control over the Z-axis. So I guess the hierarchy here is that the banana rotates along the X-axis. The trousers will rotate along the y-axis, including the giant flywheel, and then the flywheel itself will spin along the z-axis. Can't really see that turning because it's the same thing, but it is turning along that z-axis. And that's it. So if we unhide everything again, we have all of this sitting inside the wheel. It all rotates as it rotates. And hopefully in the end we'll have a nice driving droid here. Ah, perfect timing. I just crashed the program doing all my rotation. So glad the video's over. Yeah, any questions, feel free to leave them on the Facebook or the blog, and I'll try to answer them. Or check out James Bruton's videos. He tends to explain them with a little bit more intelligence than I do. So, yeah, I hope this will make you appreciate the posts I post on Friday more. You can kind of see where all the parts are at. And I actually do have a video up on my blog now of this exact mechanism driving around on my living room floor. So, all right, that's it. I'll post up again next week, maybe a video about the head mechanism.